Okay, here's warm-up 8.4. All right, we're going to write a rule for this sequence. So first I have to figure out, is this arithmetic or geometric? And this one, the pattern, it's doubling from term to term. We're multiplying by 2. That means it's going to be geometric. Okay, so that means the specific term formula would look like this, and that's what I'm going to build my rule out of. So I'm just going to plug in what I can into this. So the first term is 3, the ratio is 2, and then I've got n minus 1, and that's my rule. Now I can find any term I want using this new formula. Okay. One thing I want to point out, I keep seeing mistakes like this. I see people simplify this into 6 to the n minus 1. You can't do that because it's really 3 to the first and 2 to the n minus 1. So you can't combine those. You can't multiply them together. We'd have to do the exponent first, and we don't know what the exponent is. It's an unknown number minus 1. Okay, so just like this. Okay, all right, so now the 74th term is pretty easy to find. I just use this formula I just wrote. Okay, and once again, this is not 6 to the 73rd. That's not the same thing. Yeah, I'll even write it here. This is not 6 to the 73rd. So what I want to do is use my calculator, 2 to the 73rd, and then multiply that by 3. And I got this number, which is in scientific notation. Notice it's E22 at the end. That means times 10 to the 22nd. So this is about 2.83 times 10 to the 22nd. That means the decimal is moved 22 spots to the right from there. It's a large number. Okay. If I'm looking for the sum of the first 74 numbers, then I need the sum formula for geometric series, and here it is. Okay, all right, so I'm looking for the sum of the first 74 here. My first term is going to be 3. I can see that up there. The ratio I already figured out was 2. And I'll put in 74 for n. Okay, all right, so I'm going to start simplifying this. In my calculator, I'm going to start with this. Don't simplify that -1 to the 74th. That's not the same thing, right? I have to do the exponent first, just like on the previous two. So 2 to the 74th is this number. It's in scientific notation. I'm going to do 1 minus that. So I'm using the second and then that negative button to get my last answer. That'll just use that same decimal. So 1 minus that long decimal. This is my numerator. Still in scientific notation. My denominator is going to be -1. So I'm going to divide this by -1. And then the last thing would be to multiply by 3. Okay, I did all that on my calculator, but I didn't round as I went. I was using the long decimals in there as I went. And now I'm going to round this a little bit, so this is going to be about 5.67, heads up, times 10 to the 22nd. Right, that's in scientific notation again. Okay. All right, this tells us, hey, this is an arithmetic series, so the arithmetic sum formula, you take the number of terms times the average of the first and the last terms. Okay, so it's going to be 81 total terms here. And I'm going to need to build my first and last terms, so let's go ahead and do that. First term, I plug in a 1 into 2k minus 3. The last term is going to be when I plug in 81 into 2k minus 3. Okay, so let's see, the first term would come out to -1. Get all the stuff in the middle, and at the end, 2 times 81 minus 3 is going to come out to 159. Okay, so there's my first and last terms. That's what I'm going to average down here. And this is 158 divided by 2 times 81. It's going to come out to 6,399. Okay, one more problem. We've got a geometric series. This time we know the 10th and the 17th terms, and we want to find the 23rd term. So first thing we want to do is find the ratio. And I'm going to do that using the specific term formula. In the past, I'd written a sub 1 times r to the n minus 1, but I don't want to deal with the first term because I don't know the first term. So I'm going to change these 1's into m's. Okay. So now I'm going to plug in the two terms that I know into these two positions. You could put either one in either slot. I like to put the higher term number in that first slot, only because then when I subtract, I'm going to pause this. Okay, got distracted by the announcement there, but I like to put the higher number there, just so then when I do the subtraction, then I have a positive exponent up there, okay? Then I'll plug in the actual value of these two terms. A sub 17 is 4374, a sub 10 is 2, and 17 minus 10 is 7, okay? I'm solving this for r, so next thing I'm going to do is divide by 2. Okay, and then I would take the seventh root. Okay, and you can put in different indexes into your calculator. You could also take 2,187 and raise it to the 1/7. Okay, and if you do that, either way, you'll find that it's going to come out to 3. So our ratio is 3. So now phase 2, we're going to find a sub 23. Okay, I'm going to use this same formula, but I'm going to set it up to find a sub 23. So I want that isolated. Okay, I can put anything at either of the known terms in that second slot, but I'll keep it a sub 10, so it's the same thing there. Okay, and then the ratio, I know the ratio now, that's 3. Okay, and then for the subtraction up here, I'm going to do 23 minus 10 from those term numbers. All right. So now I'll plug in what I can. I don't know a sub 23, but I know a sub 10 is 2. And 23 minus 10 up there is 13. Okay, and now I just do the PEMDAS. Remember to do the exponent before the multiplication. So let's see, 3 to the 13th. Multiply that by 2. And I'm going to get, let's see, that would be 3,188,646. And there we go. Okay, that's the end of the warm-up, and I'll see you next time.